Hello guys, welcome back to the QST channel. I will be doing the chapter 6 quiz for the chemistry periodic tomorrow. Chapter 6 quizzes, my bad. Okay, let's start. This is 6.1 now. Which substance has particles with the highest potential energy? Select all that apply. Okay, if you remember the heating curve from before, this is temperature, this is time. It will be like this. This is a solid, this is liquid, and this is gas. When it's sloping, it will be kinetic energy will increase. When it's flat, potential energy will increase. So it will be like this. So as you can see, the solid has barely any potential energy, and the liquid has a little potential energy, but the gas has the highest. So when they ask for the highest potential energy, you just choose the one that's a gas, which is oxygen and water vapor. Okay, consider the following phase change. NaCl solid plus heat equals NaCl liquid. Which of the following are true about the above phase change? Select all that apply. It is an exothermic process. No, it is not, because the heat is on the reactant side. If it was plus heat here, we would say it's exothermic, but it's not there, so it's not. It's endothermic actually. It is the breakdown of a molecule. No, it's not, because NaCl is here, and then it stays the same. It does not get broken down. It absorbs heat. Yes, it absorbs heat because heat is on the reactant side. It means it's endothermic, which means it absorbs heat. It releases heat. No, I said it's not exothermic, so it does not release heat. It is an endothermic process. Yes, it is endothermic because the heat's on the reactant side. Okay. 115 grams of ethanol is placed over heat to boil. Given molar heat of vaporization of ethanol, 38.6 kilojoules per mole. The number of moles in the heated sample is what? Okay, for the number of moles use N equals M over M. The mass is 115, and then molar mass you can find it. C2 is 12 times 2 plus H5 is 5 times 1 plus O is 16 plus H is 1. You will get 46. So you do 115 over 46, which is 2.5 moles. Then the amount of heat required to boil the entire sample is what? They give the molar heat of vaporization, which means 1 mole gives 38.6 kilojoules. And you have 2.5 moles gives X. So cross multiply, you will get 2.5 times 38.6, which is 96.5. Okay. Sodium chloride vaporizes according to this equation below. NaCl liquid plus 170 kilojoules gives NaCl gas. The boiling point of sodium chloride is what? Okay, we don't have any equation or any way to find out the boiling point of anything. So you know it by process of elimination. In the choices they give you like negative 20 or something and 130 I think. So from these you just choose the highest, because you know NaCl is an ionic solid, and ionic solids always have high melting points. So you just choose the highest one, which is 1465. Okay. The amount of heat needed for 5 moles of NaCl to evaporate is what? Here they give you 1 mole of NaCl. It will absorb 170 kilojoules. So 1 mole with 170 kilojoules. So 5 moles gives what? It will be 170 times 5, which is 850. A substance is supplied with heat and starts to boil. At the boiling point, the temperature what? But the potential energy of the particles in the gaseous state what? The temperature when it's at the boiling point, remember the heating curve from before. It will be like this, flat, which means the temperature does not change. It will stay constant until all of the liquid evaporates or all of the solid melts. So the temperature does not change, but the potential energy increases. Yes, I showed you before at the plateau or when it's flat, the potential energy will increase. Okay. In which of the following places would you expect water to have the lowest boiling point? Okay. Um, when you go to a high altitude, it will be a very low pressure. And when you have low pressure, you will have a low boiling point. But when you go somewhere like sea level, it will be a high pressure, so it's gonna be a high boiling point. So you choose the highest, the option with the highest thing. And they said high altitude like Mount Everest, so this is the correct one. If they ask you for the highest boiling point, you choose sea level. Or if they have anything lower than that, you choose that. The vapor pressure of ethanol at 40 degrees Celsius is 60 millimeter mercury. A closed flask containing ethanol is connected to a vacuum pump and the pressure over the liquid is gradually lowered. If the ethanol temperature is kept at 40 degrees Celsius, ethanol will boil at what pressure? Okay, for this you have to know that when when a substance reaches the boiling point, the vapor pressure will be equal to the atmospheric pressure, or just like the pressure, normal pressure يعني, outside of the liquid. So here they gave you the vapor pressure is 60. So for it to boil, you need the atmospheric pressure or the pressure to be 60. So just 60. And the vapor pressure of every liquid increases as the temperature is raised. Yes, this is to memorize, you have to know this. Okay, we did not take superheating, but just memorize it just in case. At the normally boiling point of a liquid, the pressure is 1 atmosphere. Yes, so when they say like water has 100 degrees Celsius boiling point, that's only at 1 atmosphere, so it could change if you change the pressure. Okay, I finished the 6.1 quiz. Let's go to the next. Okay, this is the 6.2 quiz. Let's start. Which of the following are true about pure water and salty water? Select all that apply. The salty water solution boils at a higher temperature than pure water. Yes, because when the water tries to escape from like the beaker or whatever you're putting it in, the salt molecules will the salt particles will get in the way, so they won't let the water escape. So you need to boil it more so the water can escape. The salty water solution freezes at a lower temperature than pure water. Yes, because the salt will also get in the way when it tries to freeze. So it will be harder for it to freeze. So you need to freeze it at a lower temperature. So it needs to be colder so it can freeze. Pure water has 2 boiling points. No, this is obviously wrong. The salty water solution leaves a solid residue after boiling? Yes, because after you boil the water, it will evaporate and it will leave the salt in the beaker or whatever. The concentration of the salt does not affect the boiling point of the solution. Nope, this is wrong because it does affect the boiling point. If you have a lot of salt, it will increase the boiling point. A student was given three unknown tubes and was asked to identify which tube contains pure copper sulfate. Which of the following is done to identify the test tube that contains pure copper sulfate? The only way to know the how to know if it's a pure substance is by measuring melting point or boiling point, because you know that if it's impure, it will have a different melting point, right? Because I said the other particles, they will get in the way. Won't let it. Um, it will need more heat basically to melt. So if you measure the melting point and you find it exactly the same as the pure, you will know that it's pure copper sulfate. Okay. Which of the following are alloys? Select all that apply. Alloys are like solid mixtures, or basically like when two metals mix together. So it's bronze and steel. Sugar water, obviously no. Air is a gas, and distilled water is also a liquid, so no. A solution is what with respect to change of phase? Okay, a solution is heterogeneous with respect to change of phase. Even though it's homogeneous by itself, heterogeneous with respect to change of phase means like when you have this like a pot of water and it has like salt inside. When it evaporates, it will leave some salt behind, right? So that will be heterogeneous. The gas, it will leave the salt behind, so you can see the salt. It won't be homogeneous anymore. So only with respect to change of phase. But if it stays like this, you can't see the salt actually, right? It will just be clear. Okay. However, a pure substance is homogeneous with respect to change of phase. Yes, so if you just have pure water, when you evaporate it, it won't leave anything behind. So it's still homogeneous with respect to change of phase or without respect to change of phase. Okay. At the same pressure, a pure substance has a fixed boiling point, while a solution has a variable boiling point. Yes, the pure substance will always have the same boiling point at the same pressure, but with a solution with like salt in it or whatever, it will increase the boiling point or decrease it or whatever. Alloys are examples of solid solutions, just like I said before, while dry air is an example of gaseous solution because it's a gas. Air is a gas. Yeah. A solution is a what? It's homogeneous, right? Because you can't see the particles inside. It will just be one color or like the same thing, right? So it's homogeneous mixture that contains more than one compound. Select the picture that illustrates a solution. It's obviously salty water because look, it just looks like one color or one thing. Sand and water, no, because you can see the sand, it's heterogeneous. oil and water? No, because the oil floats on top, it doesn't mix. So both of them are wrong. In the given graph, which lines represent a pure substance? Remember, in the heating curve, for a pure substance it will be flat. For impure substances it will be more like this. Instead of being a plateau, it will be like this. It will be like less steep, but still not that steep. So like this. Okay, it will be less steep, but it would still be sloping upwards. So these A and B are impure, while C is a plateau perfectly. So it's pure. And since it boils at 100 degrees Celsius, it's water. Match each of the following to its type. Hydrogen and helium gas, they are gases together. If they just said hydrogen gas, you'd say pure substance. If they just said helium gas, you'd say pure substance. But since they said hydrogen and helium, you'd say it's a gaseous solution. Okay, bronze, it's a solid solution, because yeah, bronze is a solid solution. It's an alloy. Ice water, it's a pure substance because it's just water on its own. Air is a gaseous solution because it has like nitrogen and oxygen and carbon dioxide, all this stuff. Okay. Okay, for this one, the 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 alloy is this one because it's tightly packed. It's a solid. For water, you know water is H2O, so it's going to be three molecules. Like these are the oxygen and this is the hydrogen. So this is water. And nitrogen gas, nitrogen is diatomic, it's N2, so it will be two next to each other, which is this one. See, there's two atoms next to each other. Ne gas, let's leave the Ne and Xe by its own. Ne gas, it will be by its own one particle. It's monoatomic because it's group 8, right? It just stays on its own. So it will be like this, just by itself. And then Ne and Xe, which is here, there's two different particles. Okay, I finished 6.2, now let's start 6.3. Okay, this is 6.3 quiz. Which of the following steps can be used to separate the components of a mixture of salt, iron and water? Okay, first of all, the salt is going to be dissolved in the water, and the iron will stay like at the bottom of the cup or whatever you have the mixture in. So iron is basically an insoluble solid, and to separate insoluble solid from a liquid, you filter it using a filter funnel or whatever. So you filter the iron out, then you just get salt water on its own. Then you distill the water to separate from the salt. You'll get salt by its own and then water on its own. So that's it. Filtering the salt out of the solution, no, you can't filter it because it's dissolved. Filtering the iron out, yes, because it's insoluble, so you can filter it out. Using a magnet to remove the water, no. You could use a magnet to remove the iron, but it's not a choice here, so no. Distilling the water, yes. Using selective solubility to separate the iron from the salt, no, because the salt is already dissolved, so you don't need to do selective solubility. A mixture that can be separated by filtration is what? Remember, filtration is insoluble solid and a liquid. So is it salty water? No. Salty water, the salt will dissolve. Sand and sugar, that's not there's no liquid in there, so wrong. Sugar water, no, sugar dissolves in water. An alloy is a solid, so that wouldn't work. A sand water mixture, yes, that's the only one that works because sand doesn't dissolve in water and water is a liquid, yes, so it can work. A mixture that can be separated by selective solubility is what? Selective solubility is when you have two solids and you know that one of them dissolves in something and the other doesn't. For example, just like what they said here, sand and sugar. Sugar can dissolve in ethanol or water, so you can put the whole mixture in ethanol and then you'll see that the sugar dissolves but the sand will be left behind. So that's what they mean by selective solubility. The best technique that can be used to separate sand from salty water is what? Sand is an insoluble solid. It doesn't uh, dissolve in water, so filtration doesn't matter if it's salty water or normal water. The best technique that can be used to separate copper sulfate from its solution is what? Copper sulfate is just like salt or anything like that's an ionic compound like NaCl, anything like that. You can separate it by crystallization because it dissolves. Okay, so like most ionic compounds dissolve in water, so you can use crystallization for most of them. Okay, some heat is supplied to a mixture of solid iodine and salt. The iodine sublimes and the salt remains solid. There are some solids you need to memorize that sublime or sublimate يعني. They are iodine and ammonium chloride. I don't think we took this, but I'm not sure, but I'll just do it just in case. Which of the following mixtures can be separated by sublimation? Ammonium chloride, it sublimates, so you choose that one. Circle the setup used to separate a mixture of ethanol and water and underline the mixture, the setup used to separate a mixture of oil and water. Okay, A is what? A is simple distillation, actually fractional distillation, and that one is used for ethanol and water because they have what's it called? Close boiling points, and they mix together. So you use fractional distillation. But for oil and water they don't mix; they're immiscible. So you use the separatory funnel, which is B. Paper paper chromatography has nothing to do with any of this. Okay, this absorption, we didn't take it. This technique used is chromatography. Yes, cause like it's obvious, cause like you put mixtures and then they have this kind of thing, the dots, whatever. Okay, okay. So if A is this dot, so anything that's on this line is A. So this is A, this is A. Then anything on this line is B. So this is B, this is B. Wait, B, B. Then C is this one. So this is C, this is C. Now what do they want? Mixture A contains what? A and C. And then mixture 2 contains what? B and C. Mixture 3 contains what? A and B. Mixture of salt and sugar is separated by what? Remember, for selective solubility, it's when you have two solids together and one of them dissolves in something and the other doesn't. So this is the same as the sand and sugar one. You dissolve the sugar, you dissolve the whole thing in ethanol, and the salt won't dissolve in it. So That's how you separate them. Okay, and then a mixture of sodium chloride and ammonium chloride is separated by what? Ammonium chloride, it sublimes, so you separate it by sublimation. Liquid air is separated by what? In liquid air, all the components are mixed together, like nitrogen and oxygen or whatever. So use fractional distillation. Kerosene and water are separated by what? Kerosene is like an oil, so it's gonna be immiscible, or like doesn't mix with water. So use a separatory funnel, just like the oil and water from before. Okay. Okay. Which volumetric flask is used to prepare a 0.4 molar solution containing 0.2 moles of HCl? Okay, here you use N equals CV or C equals N over V. Which one? Either one, and it works. Okay, so 0.2 moles equals to 0.4 times V. So then you move, so it will be 0.2 over 0.4. V will be equal to it will be equal to 0.5, but 0.5 liters. So to milliliters you times 1,000, so 500. Concentration, you C equals N over V. Okay, it's 1 liter and 0.2 molar. So, oh wait, never mind. Okay, consider 1 liter of 0.2 molar HCl solution. What's the concentration of 0.5 liter of the HCl solution? It will be the same, 0.2, because remember, if you like pour, if you have like a cup of salty water, if you pour like a small cup of it, it won't be less salty. It will say like the same amount of saltiness, even though it's a smaller amount, if you know what I mean. So like if you if you change the volume, it will stay the same concentration. As long as you don't like add water, that's something else. Okay, 10 milliliters of 0.2 molar NaCl solution were mixed with 10 milliliters of 0.4 molar CaCl2. Calculate the concentration of each ion in the solution. Okay, first of all, you need to find the moles of NaCl and the moles of CaCl and the total volume. Let's start with the easiest, the total volume. It's 10 plus 10, 20. 2 liters, it's 20 divided by 1,000, it will be 0.02. So let's write it down. V total equals to 0.02. Okay, now to find the moles of NaCl, you can use N equals CV. So N equals 0.2 times 10 over 1,000, because you want it in liters. So 10 over 1,000. You will get, you'll get 2 times 10 to the negative 3. So let me write it down here. NaCl 2 times 10 to the negative 3. Same thing for CaCl2. It's 0.4 moles and 10 milliliters. So 0.4 times 10 over 1,000. It will give you 4 times 10 to the negative 3 for CaCl2. Now, this is not the moles of the ions, this is just the moles of the whole thing. So let's write the equation of dissociation, which is basically like NaCl gives Na plus plus Cl minus. Now we can work with this. The ratio between NaCl and Na is 1 to 1. So if NaCl is 2 times 10 to the negative 3, Na will also be 2 times 10 to the negative 3. So use C equals N over V, right? So the moles is 2 times 10 to the negative 3, because it's 1 to 1, it's the same as NaCl. Over the total volume, it's 0.02. It will be equal to 0.1. Okay, now let's do Ca2 plus. Okay, now let me write the equation for CaCl2. CaCl2 gives Ca2 plus 2Cl minus. You have to balance the charge, and see, if there's 2 here, there has to be 2 here. Okay, so now the mole ratio between CaCl2 and Ca2 plus is 1 to 1 again. So the number of moles will be the same, 4 times 10 to the negative 3. So C equals to N over V, so 4 times 10 to the negative 3 over total volume 0.02. You will get 0.2. Okay, now for Cl, you need to work in both equations, since it's in NaCl and it's also in ClCl2. Okay, and let's start with the NaCl. In NaCl, the ratio is 1 to 1, so it will be the same. So 2 times 10 to the negative 3, this is our first number of moles, plus the other one from the other equation. Here the ratio is 1 to 2, right? 1 to 2. So, wait, 1 to 2. So, CaCl2 is 4 times 10 to the negative 3. So, Cl will be what? It will be double. It will be 8 times 10 to the negative 3. So, you do 2 times 10 to the negative 3. We found it. Now, 8 plus 8 times 10 to the negative 3. All of it over the total volume, which is 0.02. You will get 0.01 over 0.02, which is 0.5. Okay, the concentration of a saturated solution is called solubility. Yes, this is a definition, you should memorize it. What's the... Okay, 278 grams of CaCl2 is dissolved in 2 liters of water. What's the concentration of ions in the solution? C equals N over V. So, we need to find the number of moles. We have the volume, so just number of moles. So, N equals M over M equals to 278 over the molar mass is what? 40 plus 2 times 35.5. You will get 111. Okay, so it's 278 over 111. It will be equal to like 2.5, but it's gonna be like a repeating decimal. Okay, this is the number of moles of CaCl2, and we can write CaCl2 equals to Ca2 plus 2Cl minus. Okay, so Ca2 plus is 1 to 1 with CaCl2, so it will be 2.5 moles the same. So 2.5 over the total volume is 2. So okay, so this is C equals N over V. So this is 2.5 over total volume, which is 2. So you'll get 1.25. Now for chloride, the ratio is 1 to 2. So chloride will be double of CaCl2. It will be 5 moles. 5 moles over to the total volume, you'll get 2.5. 0.2 moles of magnesium chloride MgCl2 is dissolved in 250 milliliters of water. The solute is magnesium chloride because it's the one being dissolved in the water. So it's the solute. The solvent is water. The molar concentration is C equals N over V equals to 0.2 over 250 milliliters. You have to convert it to liters. It will be 250 over 1000, which is 0.25. So you'll get 0.8. 70 milliliters of ethanol is mixed with 30 milliliters of water. Okay, if you have two liquids, the one with the higher volume, like the higher quantity, it will be the solvent. So it's ethanol, because since there is more ethanol than water. 2 liters of 2.5 molar ethanol and water solution is prepared in a flask. 250 milliliter of the solution is uh, are poured out of the flask into a beaker. What is the concentration of the solution in the beaker? This is like the other question we did before. If you pour out if you pour out 250 of, or whatever quantity of the solution, the concentration will stay the same always. It will say 2.5. It won't change. "50 milliliter of 1.5 molar HCl solution were poured into a 400 milliliter volumetric flask. Water was added to the etched mark. The concentration of the resulting solution is what?" See, if they just said they poured it into the flask and they did not say this, it would be 1.5. But since they said water was added to the etched mark, then you have to calculate it. So when they add water or they add more liquid, you can use the rule C1V1 equals to C2V2. Okay, and this rule, you don't have to convert to liters, so you can keep it 50 times 1.5 equals to 500 times the resulting concentration. If you convert it to liters, you'll get the same answer. 50 times 1.5 divided by 500, you'll get 0.15. Consider 250 milliliters of 0.4 molar NaOH solution. Number of moles is N equals CV equals to 0.4 times 250 over 1000, because in liters. You will get 0.1. Okay. 8 grams of a solute X were required for the preparation of 1 decimeter cubed of 0.2 molar solution. The molar mass is what? Okay, you guys know that N equals CV, so we can write that M over M equals CV, right? Because N equals M over M from before. Now if you move the molar mass there, you get mass equals to molar mass times CV. Now we can use this rule for this equation, and it's a rule you should memorize. Okay, so 8 grams equals to molar mass, we're trying to find it, times 0.2 times 1. You'll get 8 over 0.2, which is 40. The molar concentration of the salt solution is 2 molar. The mass of NaCl needed to prepare 0.5 liters of the solution is what? Using the rule I just derived, M equals mCV, you do the same thing. Molar mass is what of NaCl? Is 23 plus 35.5, which is 58.5. So 58.5 times, what's the concentration? It's 2 times the volume is 0.5. You will get 58.5. Okay. What's the molar concentration of a 1 decimeter solution in which 0.5 moles of sodium carbonate is dissolved? You use C equals N over V. So 0.5 over 1 is 0.5. How many moles of a sodium carbonate should be dissolved in 0.1 decimeter cubed to make a 0.5 molar solution of that salt? Moles, so N equals CV equals to 0.1 times 0.5 equals to 0.05. What volume of the solution should be used to dissolve 0.1 moles of sodium carbonate, knowing that the concentration of the resulting solution is 0.2? Suppose volume of sodium carbonate is negligible. So use N equals CV or C equals N over V, whatever. N equals CV equal, so then it will be 0.1 equals to 0.2 V. You will get 0.5 because 0.1 over 0.2. Student wants to prepare 100 centimeter cubed of 0.1 molar sodium carbonate solution. Find the mass of sodium carbonate required to prepare this solution. The mass is what? They want the mass, to use this rule, M equals M CV. So what's the molar mass first? They give you sodium carbonate above here, it's Na2CO3. So it will be 2 times 23 plus, wait, plus 12 plus 3 times 16. This will be 46. This will be 12. It will be 58 plus 48. It will be 106. So 106 times C is what? 0.1 times the constant times the volume is 100 centimeter cube. In they want it in decimeter cubed or liters, so divide by 1000. It will be 0.1 as well. So you will get the answer to be 1.06. Okay. Okay, this is the 6.6 quiz. I want to be doing 6.5 because it's not included. I don't think it is. Anyway, it's an easy section, so I'll skip it anyway. Which of the following are true? Pure water does not conduct electricity. Yes, it's not true. Only when there are ions dissolved in it, it will conduct electricity. A salty water solution conducts electricity because of dissolved ions. Yes, because the positive and negative ions will let the charge move through. Pure water can conduct electricity. No, it cannot. Conductor is a substance that does not conduct electricity. No, it does conduct electricity. Conductor generates electricity. That's wrong. No, it just allows it to pass. Which of the following can conduct electricity? Glucose, no, because it's a non-metal. And yeah, salt is an ionic compound, so it can conduct electricity. Calcium chloride is the same ionic, so it will conduct. Silver nitrate, also ionic, it will conduct. Silver chloride, even though like silver chloride has very low conductibility, so it doesn't count, even though it's ionic. It's the only exception, I think. Which of the following are the predominant reacting species? The predominant are the ones that are forming the precipitate, which is the solid. Look at the solid here. It's FeOH. So which ions are forming this? Fe2 plus and OH minus. So these are the predominant. The rest, these two, we call them spectator ions. Okay. The net ionic equation is the equation without the spectator ions. So you just cancel this, and that's the net ionic. It's the same thing here, but you just have to be careful to balance the charge. See here, this Fe2 2 plus and this OH minus. So you have to balance the charge. You have to have 2 here also. So it will be 2 minus and 2 plus. or else it will be wrong. The formation of a solid from a solution is called precipitation. Okay, this is the definition. Write the net ionic equation of the above reaction. Again, you do the same thing. This is the solids, copper hydroxide. So you cancel this one, because these are not forming the thing. See, it's Cu2 plus and OH minus. So you need to put a 2 here to keep it balanced. 2 minus and 2 plus. So that's the net ionic. Okay, this one is a bit hard. Okay, in the other question like this, I found the moles first, but here they gave it. So let's just write it down. Na2SO4 equals 0.1 moles, and zinc chloride is 0.2 moles. Okay, now let's write the equations. Na2SO4 gives 2Na plus, because you have to keep it 2, plus SO4 2 minus, SO4 2 minus. Then zinc chloride gives zinc 2 plus 2 Cl minus. Okay, for Na, here's 1 to 2. So Na plus will have 0.1 times 2 moles, which is 0.2. So C equals 0.2 over the total volume is what? 50 centimeter cubed plus 150 is 200 centimeter cubed. 200 centimeter cubed to liter or decimeter cubed, it will be divided by 1000, which will be 0.2. 0.2 for 0.2, it will be 1. So it will be 1 molar. Now for SO42 minus, it will be 1 to 1, so it will be 0.1. It will be the same as Na2SO4 is 0.1, so C equals 0.1 over total volume is 0.2, so it will be 0.5. Now for zinc, the ratio is 1 to 1, and here you have zinc chloride is 0.2 moles, so 0.2 over 0.2 is also 1. For chloride, it's 2 Cl, so it's going to be double, so it will be 0.4 over 0.2 equals to 2. In an experiment, 0.5 moles of chromium nitrate crystals in enough water in a 100 milliliter volumetric flask filled to the calibration mark. Calculate the number of moles of each ion in the solution. Okay, so let's write the equation first. CrNO3 will give, you reverse crisscross, so you bring the 3 up here. Cr3 plus this is a 1 here, so it will be negative NO3 minus. To balance the charge, you put a 3 here, and you put a bracket 3 for all of it. Okay, now you have the, what's it called, the balanced equation. Wait, okay, now you can find the ratios. This for Cr it's 1 to 1, so it's 0.5 moles, the same thing. And for nitrate it's 1 to 3, so 0.5 times 3 is 1.5. They don't ask for concentration here, just the moles. Okay. Okay, this is the 6.8 quiz because there's no 6.7 quiz. Which of the following are true about molecular solids? Molecular solids have low boiling points. They do not have high melting points. That's for ionic solids and metallic solids. So no. Some can conduct electricity in water. Yes, there are exceptions like acids, like HCl and some others. They are made up of ions. No, that's ionic compounds. They do not dissolve in water. Wrong, because sugar is molecular, but it still can dissolve. Molecular solids is anything um, that's non-metals. Even if it's a liquid, for some reason it's a molecular solid. Sugar, yes, it's molecular solid. Sodium chloride, no, it's ionic. Wax is a molecular solid. Hydrogen chloride, even though it's not a solid, it's like it's a gas or a liquid, it still counts, so you choose it. Dry ice is carbon dioxide solidified, so yes. Okay. Okay, guys, I'm gonna assume that this question is not included because it's limiting and excess, and I think Mr. said the only thing limiting and excess that we have is knowing which one is a limiting reagent, and this one is like very complex, so I don't think it's gonna come, so I won't bother explaining. Okay, this is easy, just Pb is lead, SO4 is a polyatomic ion, it's sulfate, memorize it. Silver bromides, AgBr, and Mg is magnesium, NO3 is nitrate. You don't say magnesium dinitrate because this is not a molecule or a non-metal, what's it called? Covalent compound. It's ionic, so you don't say the di or the tri. Okay, concentration of calcium ions. Okay, wait. CaCl2 is Ca2 plus 2Cl minus. So, first of all, let's find the moles. So N equals Cv equals to 0.2 times 120 divided by 1000 is 0.12. So 0.2 times 0.12 will give you 0.024. Okay, so Ca is 1 to 1, so it will be 0.024. So 0.024 divided by the volume 0.12, you'll get 0.2, which is the same thing as the original. Anyway, then chloride is going to be double that, so it will be, what's it called? It will be 0.048 over 0.12, you will get 0.4. Okay. 5.85 grams of NaCl is added to 12 milliliter of 0.2 molar AlC aluminum chloride solution. Water is added until total volume of the solution is 150. Calculate the concentration of all ions given that both compounds are completely soluble in water and no reaction takes place between them. Okay. Okay, first of all, let's find the moles of each one. For NaCl, we can find it N equals M over M. So 5.85 over 58.5 equals to 0.1. So let's write it down. NaCl and NaCl equals to 0.1 moles. And for AlCl3, you use N equals Cv, since they give you the volume and the concentration. N equals Cv, so 0.2 times 12 over 1000, because you want it in liters, you will get 2.4 times 10 to the negative 3. Okay, now they want the concentration of aluminum ions. So okay, no need to do the whole equation thing. You see that Al is 1 here, so it will be the same as the AlCl3. So it will be 2.4 times 10 to the negative 3 over the total volume is what? 150 milliliters, which is in liters 0.15. You you'll get what? You'll get 0.016. Okay. For sodium, you can see that it's also 1 here, so you don't need to do all that. So 0.1 over 0.15, you will get 0.666667, so it's just 0.67. And then for chlorine or chloride ion, it's in both of them. In the first one it's 0.1 because 1 to 1 again, plus in the second one it's AlCl3, so it will be 3 times 2.4 times 10 to the negative 3, so 3 times 2.4 times 10 to the negative 3, all of that over 0.15. You will get 0.7146, so it's just 0.71. Okay, calcium carbonate. Calcium is group 2, it's Ca2 plus, and carbonate, you memorize it, it's CO3 2 minus. So once you have once you have two with the same charge balance, you don't need to do crisscross. Just put them next to each other. Just CaCO3. Okay. Iron 2 chloride. Iron 2 means it's Fe2 plus. The 2 or the 3, whatever they put in, like sometimes they put iron 1, iron 3. That's what the charge is, because the transition metal changes. So Fe2 plus plus Cl minus. The charges aren't the same, so you have to crisscross 2 and 1, so it will be FeCl2. Okay. Then magnesium bromide. Magnesium is group 2, Mg2 plus Br is group 7, so it's minus. So then you crisscross, so MgBr2. Which of the following are true about ionic solids? They conduct electricity when molten. Yes. They have high melting point. Yes. They have high boiling point. Yes. They are made up of molecules. No, that's for covalent compounds or molecular compounds. K plus is potassium, it's a potassium ion. H plus is hydrogen ion. Ca2 plus is calcium ion. And NH4 plus is not ammonia, it's ammonium. So don't get confused. And H3 is ammonia. So this is ammonium. This is the ammonium ion. Cl minus is chloride ion. OH minus is hydroxide ion. SO42 minus is sulfate ion. and NO3 minus is nitrate. Sodium iodide is a salt that can be mixed with sodium chloride to produce iodized table salt. Sodium iodide is a lattice structure. Yes, because it's an ionic compound. We know because sodium is a non-metal. Sodium is a metal, and iodide means iodine. So it's a non-metal and a metal which is ionic. So it's a lattice. The structure is composed of oppositely charged ions. Yes, because it's going to be Na plus and I minus. And the type of bonding that holds them is ionic bonding because it's an ionic solid. Okay, this one that you just cross Mg2 plus and O2 minus. Since they have the same charge too, you don't do crisscross, you just put them next to each other. MgO. NH4 plus and Cl minus, they have the same charge plus and minus, so just put them next to each other. NH4 Cl. Ca2 and N3, you do crisscross, so it will be like this. It will be Ca3 and N2. Al3 plus and SO4 2 minus. Crisscross, it will be 3 and 2. You don't add the 3. You don't add the 3 to the 4. Wrong. You have to put brackets and then put the 3. You can't add the 3 to the 4, or it will be wrong, because it's a polyatomic ion. Okay, that's it for the chemistry chapter 6 quizzes. Good luck with your exams, and I hope you all pass.